There is a reason why the Black Sea is called black. It comes from the hostility that greeted its first explorers, the fierce storms, and the intense fog that steals the light. 2 millenniums later, GSP and TPAO decided to bring a splash of colour to the Black Sea. That is why the giant yellow topside rises above the water. Of course, it was not out of great artistic sense which led to the installation of the offshore platform, but out of economic necessity. Now the 7-kilometre long, 12-inch diameter pipe supplies natural gas, whilst following the course of industrialisation and economic development, as Turkey is expected to double its natural gas needs by 2030. And so the offshore construction project, including the installation of a steel jacket, is 101 metres high and weighs 1,366 tonnes. This makes it one of the largest modular double-decked platform topsides in the Black Sea.
The offshore construction platform was designed to extract, process and deliver it to shore the natural gas from Akcakoca field.
In this context, GSP's capacity to develop such a large-scale project was decisive. If the truth be known, this kind of construction was not carried out in the Black Sea until GSP entered the offshore construction market. Installing a 7-kilometre pipe is not like dragging a hose to sprinkle the garden. It is a challenging task, even with the appropriate technology. And when that 7-kilometre pipeline is being laid on the seabed, it is not only extremely complicated, but dangerous too.
All non-essential personnel, please stay clear of the pipe tunnel, cable under high tension.
You can just stand by there, mate.
The entire operation may seem slow, but it has to follow certain steps. Each and every one of those steps is very important and consequently followed very closely.
The pipeline that connects the platform to an existing pipeline that TPAO had was about 7 kilometres long, 12 inches in diameter, about 1,000 tonnes of pipe. This was installed by the GSP Bigfoot 1. An anchor was set adjacent to the platform location to hold the pipe at the right position for the startup. The pipe was then laid progressively to the tie-in point on the existing pipeline.
Because of GSP's constant pursuit of perfect performance, GSP Bigfoot 1 is equipped with the most modern navigation, power generation and pipe laying systems. The operational crew consists of 134 people. This may seem a large number, but these personnel are the specialised manpower required for installing the pipeline, the welding and the non-destructive testing. 80% of the activities carried out on board these technical vessels are welding and mechanical work directly related to the pipeline's installation. The pipeline that the GSP Bigfoot 1 installed in the Akcakoca field had specific design characteristics. The Akcakoca gas pipeline begins with a pig launcher on the deck of the Akcakoca fixed platform in Turkey's western Black Sea, and terminates with an underwater spool tie-in at an existing piggable Y fitting on the existing 12-inch pipeline to the shore. The installed pipeline begins at a depth of 95 metres at the Akcakoca platform and heads off towards the underwater Y connection at 55 metres in depth. Of course, the most important thing is to extract what you have. After you find natural gas, the next thing, in order of importance, is to extract it, not from where it wants to go, but to where you decide it should go. 2 wells had already been drilled at the platform site, and the platform needed to be set over them at a precise location. So you were going to need an underwater template. To install the template, the crew had to remove the old one, which held the first 2 wellheads in place.
We have a long history with Turkey. Starting from 2004, we drilled more than 25 wells. Very successful. with the GSP Saturn and GSP Prometheus. We need to make a re-entry and make a tieback for 2 wells and drill another 2 new wells and 1 optional.
For the untrained eye, the template is just a piece of steel. Weighing 14 tons, it is much more than being a large component of the project. It has a critical role.
-40, okay. Get them on reclaim in the water and see what happens.
Its installation on the seabed, in the dark, with errors measured in millimeters, is a laborious process that needs extremely well-trained professionals.
We use the GSP diving team and GSP saturation diving system for working at depths ranging from 55 to 95 meters. All the operations were successfully completed and we acquired a very good working experience.
Diving equipment for 12 people is installed on board GSP Bigfoot 3 and includes 3 barrow chambers and a diving bell, allowing the divers to descend to a depth of 300 meters. When acquired, consideration was given to the fact that the pressurization and respectively depressurization periods might reach 14 days, depending on the depth of the work being carried out.
We use our saturation diving team to remove the old template and install the new one. The template is a guiding piece for the future conductors, and in our case, will determine the position from the jacket.
The template was engineered, fabricated and installed to ensure that the platform would be accurately positioned over the 2 pre-drilled wells. So when the time came, the divers got ready to go to their workplace 95 meters below. The diving bell was lowered into the water. Data collected on the sea bottom was transmitted to the deck by the means of the ROV.
Okay, once we get that on, we'll go back and get a swim line, yeah? While the ROV is still there.
The safety of the operation belongs in the hands of the diving technicians, positioned on the deck of the installation barge.
Come on down to say 85 meters, and then I'll get back out there on the down line. We'll plumb it, we'll get it in the right spot, and then we'll just keep sending it down there each time, eh?
They have the task of operational timing, monitoring of the air, and biological data collected, and its delivery to the SAT diving deck controls in real time.
You've got the valve closed on the inside, Roger.
And if working 7 kilometers offshore might be considered a dangerous job, think about working not only offshore, but at the bottom of the sea. It's no wonder that the safety measures are so strict.
Safety is paramount in GSP, and all personnel involved in the project, from the employees up to the line supervisors and project and company management, have done their best to keep up the company's safety standards, and the results are visible.
The 101 metre long and 1,366 tonne steel jacket arrived at the fabrication site in so many containers that the handling personnel lost count after 200. The technical solution agreed for the fabrication, for the jacket and the topsides, was to carry out the work as sub-assemblies, thus maximising the work done at ground level. The sub-assemblies were then put together and the final tie-ins made, resulting in improved performance and safeguarding the fabrication schedule.
The fabrication took a conventional approach in that all parts were fabricated as small assemblies that were then assembled into their final location. These sub-assemblies were used to maximize the amount of work carried out on the ground and minimize the amount of work carried out at height for both productivity and safety reasons. It's worth noting that the entire project was completed without one lost time incident. Nobody was hurt. It was quite an achievement for a project of this size and type.
Over 200,000 man-hours were needed to complete the fabrication of the jacket and piles. This was a huge effort, but the professionals at the GSP shipyard did maybe their best job yet. Honestly, I've seen jellyfish in the Black Sea moving faster than the speed at which the jacket was placed on Bigfoot 2, GSP's submersible transport barge. But this was a good thing, not only because it weighs 1,366 tons, but because it doesn't have the same weight at both ends. so the slow speed is deliberate.
It is normal in projects of this type to weigh the major components that are going to be lifted, to ensure that there are no errors that have crept into the analysis that has determined the weights. So the jacket was lifted to get a final assessment of its weight, and the analysis for lifting it into the sea and upending it at location was done based on the weighed weight.
The loading of this steel monster was performed by GSP Neptune. The fabrication team, having completed their work, passed the responsibility for loading the jacket to a mixed operational team, including marine operations and onshore coordinating personnel. Once on board GSP Bigfoot 2, the jacket was positioned on the pre-installed supports and sea-fastened. It means that the jacket is welded in place. The transport armada departed and was towed to Akcakoca. Clearance to enter into Turkish waters was issued and the convoy arrived at the installation site. The jacket's voyage from shore to the installation site is long, very long, really long, and very, very slow. Luckily, we made it a bit shorter. The shear leg crane, GSP Neptune, set up at the platform's location. GSP Bigfoot 2 was brought to the stern of the 1,800-ton capacity crane, and the operation began with the removal of the welded sea fastening. GSP Neptune connected the jacket lifting slings, the jacket being lifted in a horizontal position while the transport barge was towed away. So it begins. The 1,366-ton jacket was lowered into the water and held in a floating position by lines from the floating crane and tugs. And this is one of the most spectacular things. The jacket floats. And it is not just the weight, it is the shape of it.
The jacket's designed to float, despite its weight and despite it being constructed of steel. The tubulars are all closed to provide the flotation. Once the crane had disconnected from the lifting slings and picked up on the slings attached to the top of the jacket, the legs were flooded in a controlled manner such that the jacket would rotate to its final position.
So the jacket legs were then flooded to bring the jacket to a vertical position, placed over the template, lowered over the higher docking pile first, then aligned with the lower docking pile before finally being lowered to the seabed. The operation was strictly controlled and continuously monitored underwater by means of an ROV.
Let me know when you're happy with the tension, okay? I'm going dead slow ahead here for you, okay?
The platform jacket was developed for a depth of 95 meters and supports up to 6 well conductors, topside facilities with well testing and possible future gas compression, 4 risers and 3 eye tubes for future underwater well tie-ins located at east, west and south sides, together with a 12-inch diameter export pipeline riser. The fabrication of the topsides was carried out in the GSP shipyard simultaneously with the fabrication of the jacket. Just to get an idea, the main deck has an area of 800 square meters. They build residential areas on smaller pieces of land. Although the specifications are enormous, the process is quite simple. Step 1. Lift the topside. Step 2. Take the topside away from the quay to make room for Bigfoot 2's transport barge. Step 3. Bring Bigfoot 2 to the quay. Step 4. Bring topside back over the transportation barge. And Step 5. Lower the topside onto the barge. Of course, it is simple when you have well-trained professionals like those at GSP.
We use our technical vessel, the submersible transportation barge, GSP Bigfoot 2, and the floating heavy lift crane, GSP Neptune, the only one crane which is capable to lift 1,800 tons in the Black Sea area.
From now on, it is fast forward. The departure clearances and permits were obtained, the towing bridle is attached, the approval for the tow obtained, and the flotilla sent to Akcakoca. Again, slowly, because slow makes for perfect operations, and perfection means profit. Based on a favourable weather forecast, the installation team received approval for the deck lift. The shear leg floating crane, GSP Neptune, set up at the platform's location, and the deck transport barge, GSP Bigfoot 2, was brought to the stern of the 1,800-ton crane. You need a large crane when you have to lift 800 tons. The sea fastening removal operation was carried out whilst the crane was connected to the deck lifting slings. GSP Neptune lifted the topsides and the transport barge was towed away. The deck was positioned over the jacket and lowered onto the main piles. The lifting slings were removed, and with the operation safely completed, the crane moved away from the platform location.
After the topside was placed on top of the jacket and welded down, we set up the conductors to be used for the feature drilling operation, including connection from existing oil heads to the surface installation from topside.
The offshore installation barge, GSP Bigfoot 3, set up at the platform's location, and the deck legs were welded to the piles.
Completion of this project involved a significant human undertaking. At its peak, there were approximately 200 people working offshore, at the same time as 200 people in the fabrication yard, supported by about 50 people in project management and engineering. Most of the engineering people and most of the project management and supervision had extensive international experience before commencing this job. This project was successful because of the efforts of everybody involved and the experience of the supervision and engineering that were involved.
Putting 3,000 tons of steel in the middle of the sea is a tough job, and until GSP, pretty much an impossible job on the Black Sea. So these men did a great job.
GSP committed a number of vessels to the project. The GSP Neptune is a 1,800-ton capacity offshore lift crane. The GSP Bigfoot 2 is a submersible transportation barge. The GSP Bigfoot 1 is a pipelay vessel, and the GSP Bigfoot 3 is a work barge with saturation diving support. To support these vessels in their work were a number of anchor handling tugs and supply vessels. Certainly, equipment's nice to have, but without people, you can't do anything. They are the most critical resource in any undertaking, and the people are what made the project a success.
Now the Akcakoca well is ready for extracting, as a result of the impressive technical armada used to complete the job. So a chapter ends, but another one begins. This is called GSP 31. GSP 31 is a modular drilling rig with a bootstrap type drilling derrick, which can be used for onshore and offshore drilling, and exceeding the MODU's operating limit of 90 meters water depth.
This operation was very successful for us. We just lifted from the beams. We need to put this GSP 31 on a Bigfoot 2 and securing, sea fastening to be transported on the location.
This modular drilling rig will be installed on the top side of the Akcakoca platform, whilst being assisted during operations by the work and accommodation heavy lift barge, GSP Bigfoot 3. These shiny new pieces of steel are prepared to do the entire dirty job. So the job is done. The people who built it have every reason to be proud, and the people who will benefit from the Akcakoca platform will be pleased. Not only because they added a little colour to this Black Sea, but because, as planned, a very large part of Turkey's natural gas needs were covered. And since this is not only about the technical achievements, but about people as well, we need to reiterate what Howard Cleave said so well. Equipment's nice to have, but without people, you can't do anything. And the people are what made the project a success. So, whichever way you look at it, this was a great success.